So the program of today is going to be to talk about what are the consequences of nutrients deficiency or excessive nitrogen when we are talking about winemaking. So to understand the importance of yeast nutrition, we really have to understand what's happening if we don't have enough or if we have too much. We are going to talk about what the yeast needs in terms of nutrients. A lot of people talk about YAN. Yes, the yeast needs some nitrogen, but not only. You know, it's like pretty much like humans. We need protein, but not only. We also need some fatty acids, some sterols, some vitamins, some minerals. The yeast does too. We'll talk about a nutrition program for the yeast, so what we recommend and how we can help you having better fermentations and better yeast metabolism. And then we'll talk about the last step will be focusing about aromatic production and how through the yeast nutrition we can actually orientate and direct the aromas that the yeast are going to produce. Okay, everything that is about yeast nutrition is about having a balanced diet. So you will see the yeast needs are not only YAN, are not only nitrogen, and as we are. So we need a lot of different elements to be healthy. So does the yeast. So to start, the consequences of a nutrient deficiency, they are many. So when you don't have enough nutrients for the yeast will have a poor development. So we'll have actually not enough yeast that develops, and they will develop poorly. This will induce or results in a stuck or sluggish fermentation, and also a risk of microbial contamination, because if the yeast is not strong and dominant, other microbes might be taking over. Then the yeast is going to produce H2S. So that's kind of when there is not enough nutrients, the yeast can't transform any sulfur molecule into amino acids. So she will expulse them as H2S. So important to have a good nutrients program for this. The yeast is going to be stressed as well. When the yeast is stressed, she produces higher sulfur combining molecules, such as ethanol, but also of flavors such as VA and reduction, reduced molecule. The yeast is going to stop at its metabolism too, which means we are not going to go from sugar to alcohol, but we will stop in the middle, and the yeast is going to expulse some of this molecule, such as ethanol again. So acetaldehydes, we will have a higher sulfur combining rate, and also stuck and sluggish fermentation. And the last point of a nutrient deficiency is that there is a lower aromatic performance because the yeast is not focusing. Basically, the yeast will focus on surviving, trying to just be there, you know, and she will be in a surviving mood, surviving states, which means really no focus on aromatic performance and little focus on finishing fermentation. So to make sure we have a finished fermentation, complete fermentation without off aromas, and then if we want to optimize the yeast metabolism, it is important to really focus on nutrients. You will see here I talk nutrients, I don't talk nitrogen. Again, we are talking about everything that the yeast needs. Then what happens if you have excessive nitrogen? That's here I talk nitrogen. It could happen, you know, you have like very, very high YAN. And in this case, usually the reaction is, okay, I have very high YAN, I don't need anything, the yeast already has everything she needs, which is actually not true. First, because the yeast can actually lack of other nutrients, so it's always important to balance the diet of the yeast. But also having excessive nitrogen usually results in excessive biomass. Excessive biomass will induce deficiency. So you have too many yeast because at the beginning they use the nitrogen to build population. So they have too many yeast, they need a lot of food and they don't have it anymore because they use it to build population. So you have deficiency induced and stress induced. Too many people in the same place. The other risk is that you're going to have a residual nitrogen. So the yeast is not going to use everything that you have, and so other microbes can. So you will induce a risk of microbial contamination. There is a reduced aromatic complexity just because the yeast has to eat everything she has. So it's kind of, again, like you focus the metabolism of the yeast on using nitrogen and that's it. And then when there is usually when there is too much DAP or too much ammoniacal nitrogen, there is a production of ethyl carbamate, which is a cancerogen molecule, which in some countries, such as Canada, can be checked and make the wine legal or not. Okay, so deficiency in nutrients is a big problem when we want to control fermentation, but not only, you know, I'm not talking only about stock fermentation. I'm also talking about optimized metabolism of the yeast, preventing reduction, preventing VA, preventing stress of the yeast, which then induce problem of malolactic sometimes, or problem of second fermentation when we talk sparkling, and also just optimizing yeast metabolism. When you have too much nitrogen, the solution is not to do nothing. You do want to make sure the yeast will have enough nitrogen to finish the fermentation, and you want to make sure there is enough sterols and fatty acids for the yeast to build a good membrane. Okay, so let's talk about what the yeast needs. That's actually what is really important. So first, at the first step of the development of the yeast, its life cycle, the yeast actually needs to develop cells. For this, of course, she needs some nitrogen, but she needs also sterols and fatty acids, which are part of her membrane. So the membrane is actually mostly made of fatty acids and unsaturated fatty acids and some sterols. And this is essential. Without a good membrane, the yeast will not survive and so will not even ferment. So we need good membrane, and then we need some protein, of course, to start to develop. So the yeast needs nitrogen and sterol fatty acids at the beginning, at the moment of development. Usually that's when we talk about rehydration. Then you need to feed the yeast. When the yeast is at its peak phase, so the yeast already start to develop, have enough cells, and now she's gonna ferment. To ferment, it's like running a marathon. You need the yeast to have good nutrients. Here she needs assimilable nitrogen, vitamin, and mineral salt. Okay, so at this moment, it's really about having a quality nutrition. So you're working on really like a marathon. You're working on accumulating nutrients so the yeast can use it as she needs to. And then sometimes giving her a little bit more boost of nitrogen to help her going to the next step and, you know, keep finishing fermenting. Towards the end of the fermentation, there is a tired population of yeast. They all are tired. They are starting to die. And so at this moment, they start to stress. So it is essential to use detoxifying agents toward the end of the fermentation to really help the yeast being in a good stage and finish the little bit of sugar left. Okay, without stress. So that's what the yeast needs. That's life cycle of the yeast is really sterol fatty acid at the beginning, nitrogen when it's the peak of fermentation, which is usually around like 3 days after. We usually call it the 1/3 of sugar depletion. And then at the end, reduce the yeast stress if there is any. So to go a little bit deeper in each of these steps, the first step is to protect the yeast for optimal development and increase the resistance through the full fermentation. So here we are really focusing on the membrane of the yeast. We are actually not talking about YAN. We are not talking about nitrogen. Just to give you an idea, this is a yeast cell, And if we do a zoom on the membrane, so again, like if the membrane is not integral, if the membrane is not resistant, the yeast will not survive, and the yeast will spend their time and their energy building the membrane and not ferment. Okay, that's the first thing the yeast does, is making sure she has a safe membrane so she can survive. So the membrane is essential. The membrane here, when we do a little zoom, you can see there's many molecules, mostly this little blue molecule with these green legs. These are unsaturated fatty acid. Actually, the unsaturation is the leg that is folded. And the goal of this is really to have space and to make it fluid. If you look at the little graph at the bottom here, very saturated fatty acids membrane will be very viscous, very rigid, and doesn't let any space for movement and for bigger molecules to, for bigger molecules. So we really want a fluid membrane. So the big orange molecule you see here, which are proteins, they are actually transfer proteins. So they are sometimes tunnels, sometimes molecules that move shape, just to make sure we can import and export molecules into the yeast cell. So nutrients, but also aromatic precursors and expulsing aromatic compounds. There is, a lot of pH regulation that happen. There is a lot of signals that come out and in from each cell, yeast cell. So a huge amount of movement of this yeast to adapt to cold or hot temperature. The yeast needs to change shape. So very important to have a fluid membrane, a membrane like this with a lot of unsaturated fatty acids that leave space to movement. We don't want a rigid membrane. Rigid membrane will end up with stack fermentation. So for the membrane, what is essential is sterols, unsaturated fatty acids, and pretty much that's really the essential. This will improve the membrane fluidity. To have a good membrane fluidity, it will increase the yeast resistance to temperature, to stress, to alcohol. It gives the opportunity to the yeast to adapt and react. So you limit the stress. You also ensure a good yeast cell, the membrane exchange, so a good fermentation activity and a good metabolism. Okay, so this is essential, and I'm not talking nitrogen here. I'm really talking sterol unsaturated fatty acid. How to get them? So they are naturally present. Usually, they are naturally present from the grapes in the juice. So usually they are in the lees. So when we are talking whites and rosé, if you do a strong clarification, you will need to supplement. You always kind of do need to supplement. It's always better. We have been seeing this over and over since years, that when we use rehydration nutrients, we always have better performance, better fermentation performance, so kinetics, but also better aromatic performance of the yeast. So our solution is called EnoSteam. EnoSteam is a yeast protector that really will promote the healthy cell development. So it is vitamin, minerals, sterol, ergosterol, and unsaturated fatty acids. No nitrogen present here. It's a product that we recommend to use at yeast rehydration. And if you do ferment with wild yeast without inoculation, you can add it just at the beginning of the fermentation. Your native yeast will still process this nutrient. So you will still help your natural or native yeast to build better membrane and so have a better end of the fermentation. We recommend to use 20 grams per hectoliters, but in fact, it's 1 gram per gram of yeast. So if you do inoculate at 40 grams per hectoliters, we would say use 40. Then if you are talking about very low YAN, so higher stress for the yeast, we're gonna add 10 grams per hectoliters more. If you are talking about very low turbidity, so naturally the juice will be very low in sterols and fatty acids. So you will want to put more. If you are very low temperature or very high temperature, we will add more as well. And if we are at high Brix, we will add more. Just anything that will make the yeast more stress or the fermentation more difficult, we are gonna add a little extra steam to make sure the yeast is actually gonna be strong, resistant, and ferment until the end. Okay, so the classic way to prepare it is you have your water where you will put the yeast. You can add your nutrients there and you mix it in water, and then you put your yeast. You wait usually 20 minutes, and then you start the acclimation of temperature if needed. Some results about an steam. So I told you it's better fermentation kinetics. We can see that there is a better yeast implantation. You can see the curve here of the, so it's a reduction of density, but it would be the same with Brix. There is a consumption of sugar. The tank that got an steam started a little bit sooner. So there is a implantation of the yeast that is faster. And so a beginning of fermentation that is faster too. You're increasing the yeast resistance. The fermentation, you see, got better toward the end and finished sooner. Actually, we finished like 4 days sooner than the control without an steam. And there is a better microbial control because we have a better yeast implantation and a stronger yeast, so better end of fermentation too. We don't have space for microbes to develop. While in the control here, toward the end of the fermentation, the curves start to be a little bit slow. There is, not a very strong viability of the yeast. They finish, but in the same time, there is some here Brettanomyces that manage to develop. As you can see, the control has a population of Brettanomyces that is 3,700, which is not huge, but enough to already start to produce volatile phenol because there is still nutrients there. While when we were with steam, we had basically no bread, and this little amount of volatile phenol was probably here before. Then we don't only optimize the fermentation kinetic, we also reduce the stress of the yeast. So less of aromas, as you can see the first graph here, we have way less of sulfur compounds such as H2S or methanethiol, dimethyl sulfur. So all these compounds that are reduction, particularly H2S, we don't produce them because the yeast is not as stressed and the yeast has a better metabolism. Way lower VA in finished wines and a better aromatic expression, way more thiolic compound here in this example, because the yeast has an optimized yeast metabolism. That's something we see all the time. So it's not only one trial, it is completely recurrent. So please, if you are not using rehydration nutrients, at least do the trial. You will see, you will be convinced right away your wine is going to be cleaner with a way better aromatic. So the second step in the yeast nutrition and the second need in yeast nutrition is nitrogen. So we talk about yeast assimilable nitrogen. Yeast can only assimilate ammonia and amino acid. As you can see, they're very different type of molecules. So ammonia or ammonium ion is a very small molecule that the yeast like a lot, very easy to eat. So the yeast is going to take it right away and use it as a source of nitrogen to build protein blocks. Amino acids, though, are also a source of nitrogen. They are a bit more complex molecules. So the yeast is going to take them and she can actually use them right away as building blocks. So the ammonium ion, the yeast has to use only the nitrogen and start to build block with some carbon skeleton. The amino acids, she can take the amino acid and put them all together and make a protein. So more difficult to assimilate for the yeast. The yeast doesn't really prefer amino acids because it's harder to assimilate, but once it's in the yeast, it will be way better food because it requires less energy to make protein. And also it is actually, there is no byproduct or side product except aromas. We'll go to this step. But so basically we usually can really assimilate or associate the ammonia as a junk food. It's really like you would eat just a bunch of, you know, carbs and protein from junk food. Food that you like, you want comfort food that you're gonna eat, but then after you just don't feel great. It will be enough for you to survive. It is, you know, nutrients, but it's not great nutrients. It's not with this that you will run and finish your marathon because you will need it all the time. It's really it's a fast food. It's a fast, also fast used food. And then we can compare the amino acids to, you know, the more balanced diet, a more balanced source of protein. And so with this, your body is actually gonna be having energy for the full day or for the full marathon you have to run. And it's gonna really help you being healthy, being more in shape, optimize your way to think, so optimize the metabolism of the yeast, and also smell good. That's another point that the amino acids can do. So to be a little bit more in the scientific part, so there is three ways to assimilate nutrients for the yeast through the membrane again. So the DAP or the ammonium ion are very easy to be assimilated through diffusion. So it's just a direct transfer. There is more outside than inside the cell. So it goes through the membrane without anything. You just need a fluid membrane. It goes through it, so it's a passive transport. And then the yeast, once it's in the cell, the yeast use it. Okay. It can also be through a facilitated diffusion. So there is a protein transport here, but it's not requiring any energy. Amino acids, some of them, and you know, the easily assimilable amino acids can be assimilated with facilitated diffusion. So no energy required here. And some of them, the bigger one, will require an active transport, so a consumption of energy. So that's the one that usually the yeast doesn't want to use because she has to use energy. But she should, you know, again, it's essential. Yeast is like it's really like a baby. You have to really focus on giving her first the food she needs, and then you can give her the food that is very easy to assimilate if she's still hungry. But what we want is the yeast to eat amino acids because they are building blocks of protein. So you will build more and faster proteins. They are actually assimilated and stuck in the vacuole of the yeast. And so the yeast use them as she needs. And the third point is that they are aromatic precursors. Some amino acids are with, you know, they are like with some glutathione or sulfur peptides, as we call them, so cysteine derivates or even glutathione derivates. This amino acid will be precursors of thiolic compounds, and some other amino acids are actually precursors of ester and acetates. So a lot of plus on the amino acids. As you understand, the main negative point is that if you put DAP and amino acids, the yeast will take DAP. So you have to think that first you want to add amino acids that the yeast will assimilate, and she has no choice, basically. She will assimilate the amino acids. Then if there is more nutritional need, DAP or ammonium ions can come after. And one of the key about using nutrients rich in amino acids are to actually focus on the easy to assimilate amino acids. So the one that goes through the facilitated diffusion here. So a transport that doesn't require energy. This will allow you to make later adds in your fermentation. So even if the yeast is a little bit stressed or busy with fermentation, she can still assimilate them. Please feel free to ask any question you have. So in the chat box, I will answer them at the end. I hope this part is clear. So now let me talk to you a little bit about our nutrient that is focused on organic nitrogen. So organic nitrogen is amino acids. Optiflor O, which is 100% amino acids, organic nitrogen. There is some of the essential amino acid here, but we really focus on the easily assimilable amino acids. So the little one that goes through passive diffusion, so the yeast can actually assimilate these nutrients all the way to have fermentation. You don't have to put it only at the beginning. We always recommend to put it at the beginning because so you don't have you don't give the yeast the choice between DAP and amino acids. You give her only amino acids, so she will eat them and she will just have a better metabolism. So when you give amino acid, it is a more sustainable nutrition. We call it more sustainable nutrition because it's compared to DAP or ammonia. It will not lead to a biomass overproduction. So ammonia, the yeast takes it and produces cells. You probably all realize that if you put ammonia in a fermenting tank, it foams a lot, the temperature rises very quickly, and then there is almost like a sugar crash. Then she has no more energy and it's kind of very quiet. So you have to keep adding DAP to maintain a good nutrition and so a good fermentation. With Optiflor O, you don't have to do this. You add it once and then the yeast just assimilate it slowly and store it in the vacuum and will use it as she needs. So there is this slow release, slow use nutrient that you put it all at once, but then the yeast is actually gonna take only what she needs when she needs it. There are essential amino acids in this product, so we really answer the needs of the yeast. Since we focus on these easily assimilable amino acids, they are actually the same nutritive power than YAN. So it's not gonna give you the same amount of nitrogen per se. You know, when we are measuring YAN or assimilable nitrogen, it's not gonna give you the same result, but the equivalence or the nutritive power is actually gonna be the same. This is because these amino acids can be used right away as building blocks of protein. So there is actually way more power, nutritive power in an amino acid than an ammonium ion that requires a lot of transformation. So Optiflor O has the same nutritive power than DAP, but there is no side effects such as the biomass overproduction, the spike of temperature. It is a slow release nutrient, so you can accumulate it in the vacuole and use it slowly, and it maintains the cells, the yeast cells, in really an optimal physiological state. So it is an alternative to DAP, but a better alternative to DAP. Optiflor O is also fully approved for organic wine production. The application, we usually recommend to use it at the beginning, but you have all the way until a third or even half fermentation to use it. And the classic dosage is 10 to 40 grams per hectoliter. So just to show you a little bit what I was talking about. So when I say there is the same nutritive power than DAP, so Optiflor O, as it is, 10 grams per hectoliter of Optiflor O is going to give you 5 milligrams of YAN per liter, okay? But in amino acids. These amino acids, 5 milligrams per liter of amino acids, are equivalent to 15 to 20 milligrams per liter of ammonium ion. So 10 grams per hectoliter of Optiflor O is equivalent to 10 grams per hectoliter of DAP in nutritive power. Okay? I know it's complex to understand, but it's really working. We have been doing this for many years now, and this has been confirmed many times. Here, just one curve of fermentation. Here we are looking at the CO2 production, so it's really about the activity of the yeast. The green line is the one that we have been feeding only amino acids, so only Optiflor O, and the red line is where we have been feeding only DAP. 10 grams per hectoliters for both of them. I'm sorry, there is a mistake in the screen here. It's hectoliters, not liters. And as you can see, the curves are actually very similar. There is not as big of a spike of energy when we are with amino acids, mostly because we don't make the yeast crazy in terms of activity, but in fact, we have a better activity towards the end. So we did 2 adds at the beginning and here at the middle. And you can see the spike of activity with the DAP, and here the little spike of activity with the DAP. Then towards the end, there is way less activity and the fermentation is actually a little bit slower. While with the only amino acids, we have a very frank and clean end of activity and the fermentation. Okay, so other point is that OptiFleur-O will really help optimizing fermentation. So it improves yeast metabolism. It really maintains the cells in the optimal state. It's a slow use nutrient, so the yeast will assimilate it, store it in the vacuole, use it as she needs, and it is a direct building block of protein. It really leads to cleaner wines with less off aromas, less stress. It's also having a detoxifying effect. So here you can see we're actually looking at C8, C10 compounds, which are basically some fatty acids that the yeast will produce when she's stressed. They are fatty acids that are inhibitory for malolactic fermentation. So, or inhibitory if we want to do a second fermentation in the case of sparkling wine. So it is very important to have very low concentration of this compound. And we also are looking at the residue of pesticides here, which can be sometimes a problem for malolactic or for second fermentation or even first fermentation. So when we use OptiFleur-O, which is a pink one, we reduce in a very significant way the C8, C10, and even more the amount of pesticide we find in the wine. The other thing that OptiFleur-O can do is that it will help, so by reducing the, having this detoxifying effect, reducing the pesticide and the C8, C10 concentration, plus, in fact, some of these nutrients can be, there is some micronutrients that are essential for bacteria that are in the OptiFleur-O. Bacteria can use some amino acids present in the formulation of OptiFleur-O. We really help having a lower lag phase for the bacteria and a better malolactic fermentation. This is very important when you do co-inoculation, bacteria and yeast. Using just one nutrient such as OptiFleur-O will be enough for both of them. Okay, so then if you do want DAP, you know, and we're going to talk about this, but if you are in a lower YAN situation and your ammonia is naturally low from your YAN, you will need to compensate with some DAP. Also, if you are not necessarily in the organic winemaking, you can add DAP, so why not? It's in this case, we always recommend to use a complex formulation. So you have a little bit of everything. And so you're not only giving junk food, but you give everything that the yeast can need. So some mineral nitrogen, such as DAP. This is for the easy and fast assimilation. If you're in a low YAN situation, or if your yeast still struggle and need a little boost towards middle of fermentation. You can, there is also vitamin, mineral, and sterols that will improve the yeast membrane and also just the yeast resistance of the end of the fermentation. And there is some inactivated yeast that will help with the detoxifying effect. Okay, so why would you use OptiFerm is if you don't want to use only organic nitrogen, if you are in a lower YAN situation, and if you want to do just one addition in a low YAN situation, you would work with OptiFerm. So, big question of today, how much YAN do we need? So again, we are not only talking about nitrogen here. There is a lot of other compounds that are essential, and we talked about it with steam. But when we talk nitrogen, I think I'm talking about how much YAN with every single person when I talk about nutrition. So to give you a, you know, easy to calculate answer, you can consider that to ferment 1 Brix, you will need 10 milligrams per liter of YAN. So that's a pretty good rule just to understand the needs. The more sugar you have to ferment and the more nitrogen you're going to need for the yeast to finish fermentation. Then there is a maximum. At one point, the yeast doesn't need so much nitrogen. You know, even if you have like 27 Brix to ferment, we're not going to go to 270 because then you arrive to this excessive nitrogen situation and your diet is not balanced. You don't have enough sterol fatty acid to compensate. So when we are in a high Brix, high temperature, low turbidity, all this difficult situation, but here we're talking mostly high Brix, we need to use an steam to really help finishing the fermentation. So basically we are saying the minimum of the YAN that the yeast needs, and that's actually just to build enough population to ferment, no matter how much sugar she needs to ferment, just to build a good, viable and good amount of cells, is gonna be 150. Then the max YAN the yeast will need is about 250. If you put more, that's, you know, if at 250 the yeast gets stuck, it's not a problem of YAN, it's a problem of oxygen or sterol fatty acids, detoxifying effect. It's another problem. And that's where you really want to look at the full picture here and not only the YAN. Then there is some adjustments. So 1 Brix, 10 milligrams per liter of YAN. Minimum that you need will be 150. Maximum that we go to is 250. If you need more than this, it means you need something else than nitrogen. And then you can adjust depending your yeast requirement. If we are talking about a yeast that has very high nitrogen requirement, you will do a, you know, plus 10 plus 20 milligrams per liter of YAN on the top of your Brix calculation. Speak with your supplier when it comes to yeast requirements. So to give you a big idea, and we have actually a more, you know, way more detailed table on our website, and also feel free to email me if you have any question. I will help you calculate exactly what you need for each specific situation. But in a big general idea, if you are lower than 150, you need 30 grams per hectoliter of steam at rehydration. At inoculation, put Optiflor O, 40 grams per hectoliter, just to rise your nitrogen. And then you keep compensating if you need to with Optifirm, 10 to 40 grams per hectoliter, to get to 150 at inoculation. Then you will do a second add of Optiflor O and Optifirm at 1/3 depletion of sugar. If you're above 150, you just need to use 20 grams per hectoliter of steam at rehydration, unless you are in very high Brix or low temperature, high temperature, low turbidity. And then you use Optiflor O, 20 to 40 grams per hectoliter at inoculation. And this should be enough to really reach your needs and help the yeast fermenting properly. Okay, that's really a big picture. Again, I'm very happy to help each one of you calculating the needs you have for the yeast in, you know, specific cases with your Brix and your initial YAN. So to make a little conclusion of our yeast nutrition strategy, you really want a balanced diet. Again, YAN is important, but it's not only this. We want to focus on protecting the yeast first. That's when we prepare the yeast, or when that's the first thing we will do. Step number 1 is using an steam at rehydration, 20 to 30 grams per hectoliter. You know, you use it in the water of the yeast, or you use it right away when your fermentation is about to start. Second step, feed the yeast properly with a qualitative, nutritive nitrogen. So we focus on quality, slow use, sustainable nutrition. So Optiflor O, up to 1/3 of the fermentation, 10 to 40 grams per hectoliter. If you are in a low YAN condition and the Optiflor O is not enough, you will use Optifirm up to half fermentation, so you have even time to use it later. And this will be 10 to 60 grams per hectoliter, depending what you need. And then toward the end of the fermentation, if you see the yeast is stressed, you see the curve starting to slow down, it's time to actually reduce the yeast stress. We have a detoxifier called Actibiol, which is some cellulose, there is some vitamins and some inactivated yeast. Actibiol is the best tool you have for a late addition to detoxify and help finishing your fermentation. So we'll use it after about, from 8 to 5 bricks, or even after 5 bricks, you can use it. It doesn't give you any nitrogen. It's really here to detoxify the wine and help the yeast finishing. So that's gonna really, if you follow these steps, you will have a clean fermentation that will be complete with less microbial contamination risk, with an optimized metabolism and very low off aromas or no off aromas production, such as VA or H2S. Now there is something else we can do with yeast to finish this marathon of the fermentation, but by smelling good. So you can actually orientate or direct the aromas that the yeast are going to produce with yeast nutrition. I told you some of these amino acids are precursors of thiolic compounds, and some of them are precursors of ester and acetate. So we know glutathione and cysteine derivatives are the precursors of thiolic compounds. So this, we know it pretty well. It's now all, I think it's a general knowledge now. So I want to talk to you a little bit more about ester production. We know yeast produce esters, but there is different type of esters. So there is the ethyl ester production, which are actually coming from fatty acids. This is the yeast and the fermentation metabolism, and then the amino acids metabolism. Fatty acids are used by the yeast to produce ethyl esters of fatty acids. These are a lower, so they are actually a higher threshold of aromas, so you need more aromas to smell them. But they are very delicate aromas, such as pineapple, apple, very floral, orange blossom type of aromas. So very delicate and very complex aromas. And then you have the acetate ester production, that these come from amino acids, and they actually just a little bit of these compounds will smell very strong, and they are the one we know, such as banana, pear, roses. Altogether, they really make the wine complex. It's usually giving you a baseline to lift all the other aromas. So it's always important to focus on these aromas when we talk about, higher yield grapes that don't have a lot of precursors inside them already to start with, but also some natural varieties, but also overripe aromas, overripe grapes or green grapes, anything that's any aromas you don't want to express too much. If you really boost the production of ethyl ester and acetate ester, you're gonna go over it and boost the complexity of the wine, the freshness of the wine, and so overall the appreciation of the wine. So once we understand this, we manage to make formulation of amino acids and fatty acids to help the yeast metabolize both of these aromatic compounds. So there is 2 nutrients we produced at La Motabier. One is gonna be to boost the thiolic compound production. It's called optithiol, and this is inactivated yeast rich in sulfur peptides. We don't count it in YAN. It is a very low nutritive value. So, we talked about Optiflor O that has a high nutritive power. The optithiol, optiester have a very low nutritive power because they are these complex amino acids that the yeast needs energy to take. So we want to use it before or at inoculation. From 15 to 30 grams per hectoliters, it's really about the more you put, the more you get. As you can see here, the control doesn't have much thiolic compounds. We put 15, we double the concentration at the end. This is 3 months of aging of the wine. After 3 months of aging, and then we put 30 grams per hectoliter, we double again. So we are more than 3 times more than in the control. So the wine is way more aromatic, way more complex, and way more thiolic. Very interesting in whites, in rosé, but also in reds, where it helps you boosting the fresh fruit and yeah, some floral characters. The other nutrients we developed is optiester, where we focus on amino acids and ergosterols. So here we really want to boost the production of ethyl ester and acetate of ester, but a lot of ethyl ester. So the idea here is to increase the production of floral aromas, pear, pineapple, apple aromas with a little increase of banana, but not so much. We really don't focus on the banana aromas to not make the wine heavy. What we want is to lift all these aromas of more delicate aromas, such as the floral, apple, pear type of aromas. So really, really a great tool to boost the aromatic compounds, the aromatic expression and the aromatic profile of your wine. You use them at inoculation. You can use them together. They can be used on any type of wine, and it's actually, it's working very well. We did many trials, very successful trials, and I would love for every one of you to do a trial to really see by yourself how it works, because it's pretty impressive. So as a take-home message for today, the yeast nutrition is really not a luxury. It's a necessity for the yeast. We need to feed the yeast properly. What's very important is to talk about a balanced diet. We are not only talking about nitrogen. I know that's the main one. I know that's what most of the people talk about, but that's really what I want to make sure you go home with this message today, is that it's not the only one. Yan is important, but not only. We need to also talk about sterol fatty acids, because if the membrane of the yeast is not integrate, is not resistant, and is not fluid, having a good yan is useless, because the yeast will not use it, will not ferment. So we really have to start with a good sterol and fatty acids concentration here. So you want to measure your initial yan so you can adjust it. Then you want to use an steam for rehydration to really make the yeast ready, to prepare the yeast, to train the yeast to be resistant for the long marathon and the long run she has to do of the fermentation. Second, you want to feed the yeast with very sustainable and highly nutritive nutrients, such as Optiflor O. This will give you the nutrients she needs, but will also reduce the stress and give you some detoxifying effect. So in one nutrient, you can really have a full combo here. Again, that's really into, like, imagine this is the day before the marathon where you really eat everything you need, your body is gonna store to use slowly during your run. Then Optifirm. Optifirm has some DAP in it, so at 1/3 or half fermentation, it will help you giving the last boost of energy to finish this fermentation. That's when we are in the lower yan. That's the energy drink you drink during the middle of the marathon to really finish and get this last boost of energy. Actibiol at the end of fermentation, that's the detoxifying effect. If you see your fermentation slowing down, if you know you are in a difficult situation, use the Actibiol. It will not give you any nitrogen here. It will just detoxify the environment. With this, you will run your marathon, you will finish it, and you will ensure there is no fall in between. And, you know, you do your good and clean marathon. Now, you can also do it by smelling good. And this is where you can increase your aromatic profile. You can boost some aromas here, aromatic expression with the optiester and optithiol to, yes, lift all the aromas that are already present, but also refresh them, add complexity, and just create a wine that is overall more aromatic. Okay, so thank you very much.